Analog Design Contest 2010, we designed voice-activated home automation systems. We considered the problem of physically challenged and elderly for operating electrical equipment and thereby enabling them to lead a normal life without assistance from others. According to a statistical survey, 80 million people are disabled in our country. That constitutes about 2.13% of the total population. 23% are physically challenged. It is found out that many of the physically challenged people are not interested in taking others' help for their daily routine. These people may not move from one place to other as we all do. They cannot switch on fan or light or any other equipment. They need others' help for all such kind of things. In connection with the Assistive Technology Lab, we had a meeting with physically challenged people. We discussed their problems along with doctors concerned. In this process, we identified their other abilities and we have developed a voice-activated home automation system that can control the domestic electrical appliances with voice commands of the user. This voice-activated home automation system can be trained in regional languages, which proves to be its most effective and unique feature. It is very economical device and can be made either user-dependent or independent. This project aims at controlling electrical appliances with voice commands. Voice-activated home automation system consists of mainly a voice recognition unit and a control unit. Voice recognition unit takes the voice command as input from mic, verifies it with the previously stored voice command and directs the control unit. It in turn drives the required domestic appliances. This is the voice recognition IC HM2007. This is SRAM BQ4010YMA70. latch 74LS373. Hexadecimal display TIL311. Driver IC L293D. NAND split trigger IC 74LS14. HM2007 is the heart of this circuit. HM2007 is a 48-pin dual inline package. It can record 40 words if its length is 0.96 seconds and 20 words with a word length of 1.92 seconds. 40 commands can control at most 20 appliances. External 64K SRAM can be connected directly. Multiple chip configurations are possible. A microphone can be directly connected to this chip. This is a desirable feature for a speech recognition system. Two control modes are supported, manual and CPU mode. Its response time is less than 300 milliseconds. This chip needs only 5 volt single power supply. This can be used as both voice dependent and independent. As this project is designed for assistive purposes, it is desirable to make it voice dependent. However, it can be made voice independent on the request of the user. Training of HM2007. It is trained for a specific number of commands. These commands are stored in SRAM. The digits scanned to the keypad provide the address to SRAM. Initially, 99 star is pressed to clear the previous memory. For example, let the number be pressed on the keypad is 01. Then hash is pressed. Now the chip is made ready for voice input. Let the input given be on. This input is converted into electrical signal by microphone and stored in 0x01 address of SRAM. This work is done by voice recognition IC. After the training process is over, when we again speak the word on into the microphone, HM2007 compares the previously stored command with the current word. If it matches, then the corresponding data is fed to latch 74LS373. This latch gives the data to the 2 hexadecimal TIL311 displays and the number is displayed on them. If the words are not correctly matched, it displays some error code. The error codes are 55, Word too long, 66. Word too short, 77. Word no match. Data pins of these displays are taken out for output. On. Off. Software implementation. An 8-bit data from the hexadecimal display is fed to the 74LS14 IC. Output of the man-symmetrical IC is connected to the microcontroller. This microcontroller is programmed to activate specific relays for various inputs. Microcontroller output current is not sufficient to drive the relay. A motor driver IC L293D is used. Thus, microcontroller activates driver ICs, which in turn controls the relay. These relay control operations operate the domestic appliances. On. Off. On. Off. This is the code of our project. We could successfully compile and build this code. These are the build results of our code. We tried our best to interface it with the hardware. However, we encountered some problems. Thus, we did not include microcontroller in the present video. Conclusion. Existing systems cost between $300 to $3,000. Our system can easily reach common man as a result of its low cost. Its flexibility in using native languages is a desirable feature. Mass production can reduce the price of the system from $68 to $60. Loss elimination is the most important task. However, this system can be further developed for security purposes. We sincerely thank TI, coordinators, Mentor Dr. Rajesh Kumar, and all the supporting staff for their constant support. Thank you. Have a good day.